Hi guys, this is our first intro video to calculus. So just a quick what is calculus. Um, there's these two simple geometric problems that originally led to the development of what we now call calculus. And both those problems that people had were, if you have this function, I'm just calling it y equals f of x, this blue curve here, some people were interested in finding the slope at one point on the curve. So what is the slope at this point? And then the other part of calculus is finding the area under the curve. People were interested in that. So those two problems led to the development of calculus, and it took a really long time. I don't know, a whole bunch of scientists were involved in its discovery. But in the end, they found that this function called differentiation and integration could solve these two problems about slope and area. So we're going to focus on this in our calculus course, and the area under a curve is integrals. So we're not doing that. That's going to be in university. But for slopes, this whole section is going to lead us to this thing called limits and differentiation. So finding that derivative of functions, and it will help us find the slope at one point on a graph. So that's what calculus is all about. Okay, so let's say we had this curve here. So let's just talk about how to find the slope at a point in general. So if we have a curve like this blue line, and we want to find the slope at one specific point. So it's not a straight line, so we can't just do, pick 2 points on our line and do rise over run, because the slope's constantly changing. At every point on this graph, it's going to have a different slope. So what we were talking about in Friday in class were these things called secants. So that's where we take point P and then we pick another point on our line, point Q. And we draw a line between those 2 points. And we could calculate the rate of change by doing rise over run. So like y2 minus y1 over x2 minus x1. So whatever those points are, we would just subtract their y values and then divide it by their difference between their x values. And then we should find, as you move point Q closer and closer and closer to point P, as it gets really close, the line of, or the slope of point P, which we'll just say the tangent, gives us an accurate determination of the slope. So the tangent line. So as we move point Q closer and closer and closer to point P, so as the second point Q gets closer to the point P, we get a better estimate of the slope at P. So we kind of call the slope between P and Q over here would be like an average rate of change between those 2 points. So the secants can get us an average rate of change, whereas the tangent line, rate of change or slope, same thing, whereas the tangent line here is going to get us an instantaneous rate of change. Instantaneous rate of change. So we're going to find this slope at that specific point P. So we want to figure out, instead of picking closer and closer and closer values to P, how do we get that? Essentially we want the distance between P and Q to be approaching 0. So that's kind of what limits are. They kind of talk about things that are approaching 0. So they're going to help us with tangent lines. Okay, so I'm just going to show you. It's going to get kind of crazy. Oops, another diagram here. Okay, so let's just draw a graph, and let's draw another curve on our graph here. Say we had a graph like that. And let's say we're trying to find the slope at point A here. Maybe not right there. Let's say like here. So this is point A, and we'll call the y value here f of A. We use function notation, so that's like x and f of x. So I'm just going to use A. So we're trying to find the slope at that point. So it would be great if we could just find the tangent line, because that would give us the slope. But right now we don't know how to use a tangent line to help us find the slope, other than like, you know, graphing it by hand and like actually finding another point on the tangent line. But that would be pretty inaccurate, because then we're just like graphing by hand, and like we can make lots of mistakes when we graph by hand. Or another option would be to use the graph that we have and just pick a point that's really close and find the slope. But that's not going to give us an exact answer. We want the most exact as possible. Okay, so we're going to pick a point. I'm just going to pick one wherever, it doesn't matter. And I'm going to call this point, because I want this point to be as close as possible. So this is kind of weird, but I'm going to call this point A plus H. So it's just some distance away from A. So it's like, say it's like 2 over A plus 2. But I want it to actually be as close as possible. So I want H to almost be 0, but not actually 0. So I want it to be as close to A as possible. So let's say A was like 5 on my graph, and this one was like 7. They're 2 apart. Well, I want it to be like A is like 5.00000000001 or something. Like so close together. And then we'll call the y value of that point f of A plus H. So we're just naming them things because I don't want to use actual numbers. So we know the distance between these guys is H. So if we're going to do, to find the slope of the line between those 2 points, so we're going to do like rise over run between those 2 points. So our rise here would be the difference in our y points, or y coordinates. So that's f of A plus H minus f of A. So just subtracted our y coordinates, and then the bottom is going to be the difference in our x coordinates. So for x coordinates, we're A plus H minus A, because that's what they each are. Then I can simplify this formula to f of A plus H minus f of A all over. If you notice, A minus A is going to cancel out, so there'll just be an H on the bottom, which makes sense because these are like H units apart. Okay, so this formula right here is pretty helpful in trying to find the slope of the tangent at this point, because we're going to say H, we want it to approach 0. So we can say something like that. We could say like as H approaches 0, we could actually find the slope of tangents. Well, H can't be exactly 0, or else we just have 1 point, but we just want to know like as it approaches 0, it will help us get a really good estimation for slope at this 1 point, which is what this whole calculus thing is about. Okay, so let's try it. Let's just try a graph that we're really familiar with. So let's try the graph of y equals x squared. So we know our graph of y equals x squared starts at 0, 0, over 1, up 1 on both sides, over 2, up 4, and so on, over 3, up 9, etc. Okay, so there's the graph that we have, and we have an equation for it, which is super helpful. When we start to learn more about calculus. Okay, so let's just say we picked a point. So say we picked the point 3, 9, which I have not graphed. 4, 5, 6, 7, 8, 9. So I got a point up there. So I want to find the slope of the tangent right at this point here. I want to know what that slope is at that exact point. So I'm going to find my rate of change at that one point by using this cool new equation that we just created. Okay, so my point is 3, and I'm using some random a plus h. So I already said a was 3, so 3 plus h point to help me find my slope. Okay, so if my equation is f of a plus h, so that is so that's f of, sorry, instead of y, I should put like f of x equals x squared. Okay, so on the top, f of a plus h, so f of x is equal to x squared, so f of a plus h would be equal to a plus 3 squared. So I have to sub it into my equation. So I'm trying to find out like what y equals. So if y equals x squared and my x is 3 plus h, then y would equal 3 plus h squared. Oh, I put a plus 3. Sorry. 3 plus h squared. Do you know what I mean? Minus f of a. So now I want to find out, oh, y equals x squared. Well, what about when I sub in 3? What's 3 squared? It's 9. Okay, so that's my numerator. And then on my bottom, it's just h. Okay, awesome. Now I'm just going to simplify it. So 3 plus h squared, if I expand that bracket, would be 9 plus 6h plus h squared minus 9 over h. And if I simplify that some more, the 9's cancel out, and I get 6h plus h squared over h. I notice every single term has an h in it, so I'm actually going to factor out an h. So I get 6 plus h over h. And then I can cancel these h's out. So all I'm left with is 6 plus h. So that's the slope of my tangent at point 39. But like that doesn't mean a lot to me with h. So I'm really looking at when h approaches 0, what will my slope be? Because remember, I want h to be as small as possible because I want the distance between my points to be as small as possible. So I'm going to say as h approaches 0, then the slope of my line approaches 6. So I can conclude that the slope of the tangent at point 39 is 6. And sometimes we say that using this thing called limits. We say it like this: the limit as h approaches 0 of 6 plus h is equal to 6. So these things right here are called limits. And they're going to be really helpful in this unit. So they just kind of help us when we're trying to estimate the slope at a single point. Instead of picking 2 points that are far apart, we're almost picking 2 points that are like right on top of each other. So the slope at that point is 6. Okay, let's try another one. So say we had the line f of x equals negative x squared plus 4x plus 1. So that's our equation. And let's say we want to know the slope of the curve, or the tangent to the curve at x equals 3. So we're trying to find the slope at x equals 3. Okay, so we know we've got this equation, f of a plus h minus f of a all over h. That's going to tell us our slope of our tangent, and that's something I'm just going to add in front of this, which is kind of crazy, is I'm going to add that limit thing. So I'm going to say we're this pretty much is just saying we want h to be 0, but we can't really say it's 0, so we're saying it's approaching 0. So that's what this limit thing means. Okay, so first I want to find out what's f of a and what's f of a plus h. So in this case, a is actually 3. So let's find f of 3. So f of 3, we just sub 3 in for x, so negative 3x squared plus 4 times 3 plus 1. So that's negative 9 plus 12 plus 1, and the negative doesn't get squared because it's not in brackets, it's outside. So that is 4. Okay. And then I need to also find out what a plus h is, so that's 3 plus h. So anywhere I see an x, I'm subbing in a 3 plus h. 3 plus h plus 1. So kind of crazy, but I think if we simplify it, it won't look too bad. So we got negative, so we're going to square this whole bracket. So it's like we have 3 plus h times 3 plus h, which is 9 plus 6h plus h squared plus 12 plus 4h plus 1. So that's negative 9 minus 6h minus h squared plus 12 plus 4h plus 1. And if I simplify all of this, I get negative h squared, negative 6 plus 4, so negative 2h, 12, 13, plus 4. Okay, so now I've got f of 3 and f of 3 plus h. So I'm going to sub those into my limits formula here. So f of a plus h was negative h squared minus 2h plus 4. And I'm subtracting f of a, which is 4, all over h. Okay, so then the limit as h approaches 0, 4 minus 4 cancels out, so those are gone. And then if you notice, like I did before, I can factor out an h. So I just get negative h minus 2 over h. So the h's cancel, and I just get negative h minus 2. So looks like as h approaches 0, so pretend like you're pretty much just subbing in 0, the slope is approaching negative 2. So we say the slope is negative 2. So we know right at x equals 3, for this parabola, our slope is going to be negative 2. Awesome. Okay, so just one last recap. The longest video of all time. We're talking rates of change, which is the slope of a line. So you need to know how to find the average rate of change and the instantaneous, which is like our tangent. So if we're just given an equation or a curve or whatever it looks like, and you wanted to find the slope between, the average rate of change would be like you pick 2 points and you're finding the slope between 2 points. So you're just doing this equation. Essentially it's the same thing as the instantaneous one, the f of a plus h minus f of a over h, but h isn't going to be 0 in this case. We have like 2 defined points and 2 defined y values. Like if these x values are actually like 2 and 4, it's not approaching 0, like for the h value, like these two. So that's the average rate of change, so we're finding it between 2 points, point P, point Q. Whereas if we're finding the instantaneous rate of change, that's like the slope of our tangent line. So that's where we're going to pretty much do rise over run, but that's where we're going to introduce the limits. So as h approaches 0, we're going to use the same kind of equation, f of a plus h, minus f of a over h, but we want h to approach 0. So pretty much want h to be 0. It can't actually be 0, but it actually is kind of. And this one can use the same equation, but h would just be like, this would be a, and then this would be like 2 plus 2 would be 4. So I don't know, it's like you could just write it like this, y2 minus y1 over x2 minus x1. So you're just finding the slope between 2 points, whereas this guy here, you're just finding the slope at 1 point, so you're finding the tangent line, so the instantaneous rate of change. Okay, so you should be able to calculate the average rate of change and the instantaneous rate of change on a graph or given an equation.